Hello, welcome back for the videos for chapter 5.3, the binomial distribution. There's going to be two videos today because it's a little bit longer lesson. So we're going to learn about how to prove that we are working with a binomial experiment. We're going to learn how to calculate a binomial probability, and we're also going to learn how to calculate the mean and standard deviation of a binomial distribution. So there are four characteristics of a binomial experiment. The first is that we will know that there is a fixed number of trials. Think of trials as repetitions of an experiment. The letter N denotes the number of trials. So if they don't tell you that they're going to do a fixed number of trials of the experiment, then it's not a binomial experiment. The second characteristic is that there are only two possible outcomes called success and failure for each trial. The letter P denotes the probability of success on one trial, and Q denotes the probability of failure. P plus Q always equals 1. Number 3, we have to define X. X is what we would consider the number of successes, and X can be anywhere between 0 and N. The fourth characteristic is that N trials are independent and are repeated using identical conditions. Because the N trials are independent, the outcome of one trial does not help in predicting the outcome of another trial. Another way of saying that is that for each individual trial, the probability of P of a success and probability of Q of a failure remain the same. For example, randomly guessing at a true-false statistics question has only two outcomes. If a success is guessing correctly, then a failure is guessing incorrectly. Suppose Joe always guesses correctly on any statistics true-false question with probability of 0.6. That means that Q is 0.4, 1 minus 0.6. This means that for every true-false statistics question Joe answers, his probability of success is 0.6 and his probability of failure is 0.4. And that remains the same with every time he answers the question. So when we're calculating the mean and standard deviation of a binomial distribution, the mean is equal to the number of trials times the probability of success, and the standard deviation is equal to the square root of the number of trials times the probability of success times the probability of failure. We're going to look at this later on down the road. A binomial experiment, when we are only running it one time, is called a Bernoulli trial. And we're going to do many Bernoulli trials because we're going to run it more than one time. So let's look at our first example. It says, at ABC College, the withdrawal rate from an elementary physics course is 30% for any given term. What would we define as a success? So that would be anyone who withdraws from the physics course. Even though that's not a good thing to withdraw from the course, that is what we're counting. So what would we define as a failure? A student who does not withdraw. And what is the probability of failure? So the probability of failure is Q, and the probability of Q is 1 minus the probability of P, which is 1 minus 0.3 or 0.7 is the probability of failure. Let's try that again. Example 2, the state health board is concerned about the amount of fruit available in school lunches. 48% of schools in the state offer fruit in their lunches every day. This implies that 52% do not. What would we define a success as? A success would be a school that offers fruit And what would we define as a failure? A school that does not offer fruit in the lunch. What is the probability of failure? And so P is equal to 0.48 and Q is equal to 1 minus 0.48 or 0.52. I want you to read through number 3 and try to answer that one on your own. Okay, what would we define as a success? To win the game. If you play the game 20 times, write the function that describes the probability that you win 15 of the 20 times. So the probability that X equals 15, exactly 15 of the 20 times. That's what it would look like. Okay, number 4. A trainer is teaching a dolphin to do tricks. The probability that the dolphin successfully performs a trick is 35%. Out of 20 attempts, you want to find the probability that the dolphin succeeds at least 12 times. State the probability question mathematically. We're not going to answer it. We don't know how to do that yet, but we just want to know what it would look like for the reader to read that. So it would be the probability that X, and it says at least, so at least would be X has to be greater than or equal to 12. Okay, so that would include 12, 13, 14, 15, 16, 17, 18, 19, and 20. That's at least. At the back of your lesson, you'll see that I made a table for you on the words that you're going to find and what the symbols will mean, and then how I'm going to show you to solve that in Alex. Example 5 says, decide if the following situations could be considered binomial experiments. If they are, then define the following: X, N, P, and Q. So A says 65% of people pass the state driver's exam on the first try. A group of 50 individuals who have taken the driver's exam is randomly selected. Give 2 reasons why this is a binomial problem. So we're going to actually list all. So we have a fixed number of trials, N, because 50 people are going to take the exam. Okay. And they either pass or fail. So there's 2 outcomes. Each person is independent. Of one another. The probability of success, P, is 65%, so 0.65. Q is equal to 1 minus 0.65 or 0.35. And then we also want to define X. So X is going to be anywhere between 0 and 50. So 0 of the people pass all the way up through 50 of the people pass. Let's look at B. So B says, a lacrosse team is selecting captain. The name of all the seniors are put into a hat, and the first 3 that are drawn will be the captains. The names are not replaced once they are drawn. One person cannot be 2 captains. You want to see if the captains all play the same position. State whether this is a binomial or not, and state why. So do we have a fixed number of n? So n is equal to 3, right? We're drawing, well, we don't know what n is because we're drawing, whoopsie. We're drawing 3 captains. But really n would be the number that we're choosing from, and we don't even know that. So it's either they're a captain or they're not. So we really don't know that. The other thing is because we're drawing without replacement, we are drawing names without replacement. The probability of success changes. So that fails right there, because remember that the probability of success has to stay the same from trial to trial. And this is going to keep changing because once I'm drawn as a captain, I can no longer be chosen. So there's one fewer people to choose from. Okay. So when we are doing a binomial experiment, we have some notation that we're going to use, and it's going to look like this. We're going to say that X is described as, that's what the tilde means, and it's described as binomial. So when we see B, we know it's binomial, where N is the number of trials and P is the probability of success. So let's look at example 6. It says, it has been stated that 41% of adult workers have a high school diploma, but do not pursue any further education. Let X be the number of workers who have a high school diploma, but do not pursue any further education. X takes on the values of 0 through 10, where n is equal to 10. The probability of success is 0.41, and the probability of failure is 0.59. So we would describe it as X is binomial, N is 10, and P is 0.41. If 10 adult workers are randomly selected, find the probability that exactly 6 of them have a high school diploma but do not pursue any further education. So we're just looking at how we would write it. And so that would just be find P of X equal to 6. The y-axis contains the probability of X, where X is the number of workers who have only a high school diploma. So we could we could look at this in Desmos as a graph. We're also going to use Alex to learn how to calculate these. And then B says, what is the number of adult workers that you expect to have a high school diploma but not pursue any further education is the mean. So we're looking at the mean. So the mean we said was calculated by taking N times P. So there's 10 trials, 41% of the time is a success. So that means on average it's 4.1. And then the standard deviation is the square root of N times P times Q, and that comes out to be 1.56. So we would say on average, out of 10 adult workers, we would expect 4.1 to not pursue any further education, give or take 1.56. So example 7 says, in the 2013 Jerry's Artorama Art Supplies catalog, there are 60 pages. 12 of the pages feature signature artists. Suppose we randomly sample 30 pages. Let X equal the number of pages that feature the signature artists. So So 12 of the pages could possibly feature the artist. It says, what does X take on? So X takes on 30. Well, X could be anywhere from 0 to 30. What is a probability distribution? So it is binomial with 30, and the probability for success is 12 of the 60, is because it says 12 of the pages feature signature artists. So the probability of success is 12 out of 60. So it says find the probabilities. The probability that 2 pages feature signature artists is following this. So we are going to use some of our combinations and probability that we learned in chapter 4. So when we are looking for an exact, we're going to use this formula here in Alex. So it's going to be n choosing X times the probability to the X times 1 minus the probability of X, or this is really just Q to the n minus X. So this is what it would look like in Alex. 30 choosing 2, because we have 30 cards and 2 of them are going to be successful. The probability of success is 12 out of 60 raised to the 2. And then 1 minus 12 out of 60 raised to the 28, because this is going to be 30 minus 2. And when we put that in, we get 0.0337. Okay. I am going to share my screen here, and I'm going to go to the calculator. I'm going to show you how this works. So I'm going to do right here. So 30 choosing 2, and then it's going to be parentheses 12 divided by 60 parentheses, and then I want to raise that to the 2, and then 1 minus 12 divided by 60 parentheses, and then I'm going to raise that, and I'm using X to the Y button here to do my exponent. And then it's, you can even type in here 30 minus 2 if you want. So you don't even have to type 28. And then you're going to hit enter. And then there is your answer, 0.0337. Okay, follow along on your notes for letter B. It's number 2. It says the probability that at most 6 pages feature signature artists. So at most means that should say at most 3 pages. Sorry about that. And the probability that more than 6. I'm sorry, the next one is a more than 12. Sorry about that. Sorry about that. So it should be at most 3. Let me go back to my document here. This should say the probability that at most 3 pages, because at most 3 would be 0, 1, 2, or 3. X is less than or equal to 3. So 0, 1, 2, or 3. And so we're going to use this. It's really the probability of the binomial of n comma p is less than or equal to X. And so we are going to use that in Alex. So I'm going to show you what that looks like in Alex here. So let's clear this out. So it's because the binomial distribution in Alex is always a less than. So it's going to be 30 tab 3, I'm sorry, tab 12 divided by 60. So it's 30, and then 12 divided by 60 is our probability, and then we're gonna put in 3, and then hit enter. And then we get 0.1227. Excellent. Then the next problem says the probability that more than, it should read, this is where my numbers got mixed up. The probability that more than 11 pages feature signature artists. So more than 11 would be greater than or equal to 12. So 12 or more would be equal to that. So that means we have to do 1 minus the binomial, because the binomial only does the less than. So we need to do 1 minus everything less than that. So that means we're going to do the binomial of 1 minus the binomial of 11, because it's x minus 1, which is going to be 12 minus 1. So this is what we're typing in to Desmos or Alex. 1 minus the probability 30, 12, and 60, because that's n, and this is p, and then less than or equal to, and this is x minus 1. So 12 minus 1. So I'm going to show you how that's done in Alex. So I'm going to clear this out, and then I'm going to type 1 minus, and then I'm going to click on the probability for the binomial right here above the 7, and then 30, and then 12 divided by 60, and then you can tab over and type 11 and hit enter. And that is 0.00949. And then the last part of this question says, using the formula, calculate the mean, which is n times p, so 30 times 12 over 6 is 60, and a standard deviation, which is the square root of n times p times q. So this is n, p, and q equals 2.19. So on average, out of 30 pages, we would expect 6 of them to contain artists, but feature the signature artist, give or take 2. So catch me back for the second video for this lesson.